Hello, welcome back to part two of functions. All right, so let's go ahead and get started here. So in the last video, we left off on evaluating functions, and so we're going to continue with that idea, and we will take a look at piecewise functions. How do we evaluate those? How do we evaluate functions when you don't have, when you're using variables or other letters? And we're going to look at change. Okay, so 2.1, functions continued. Part 2 of 2. Okay, so piecewise functions. So what happens is sometimes one function is not enough to represent a situation. You can think of like stock market, anything that goes up, down, flat, and then rises, and then flattens, and then decreases. It's hard to find one unique function to represent that behavior. So what happens is we use more than one function for each section where it starts to change. Okay. So a piecewise function is a function defined by more than one expression. Okay, so for example, let's take a look at this function. So suppose that I had something that behaves like a line in this function. This linear function is enough to describe that behavior. Great. But then let's suppose that this isn't enough, so that I need more than this function. Okay, so maybe this function is fine for x values that are between 0 and 2, but then less than 0, I need this function. And for x values that are greater than 2, I need this function. Okay, so this here represents a piecewise function. It's a function that's described using several pieces. Okay, so let's take a look and see how we can evaluate this. So let's evaluate the following. All right, so suppose that I want to know what f of negative 5 is. Okay, so this is how it works. This is your x value, negative 5. So it's not that you plug into all of them. Okay, so what you do is this is your x value. So you have to see where this x value falls. Does it fall in this category, in this category, or in this category? Okay, so x is negative 5. So does it fit here? Is your x value, negative 5, greater than 2? No. So we're not using this function. What about this one? Is your x value between 0 and 2? No. Okay, so we're not going to use this function. Is your x value less than 0? Yes. Then this is a function, the re-x, that you are going to use when you evaluate f of negative 5. Okay, so f of negative 5, using that first function, is going to be 3 times negative 5. And that answer is negative 15. Okay? All right. Let's go ahead and try another one. Okay, what if I want to know what f of 0 is? Okay, so again, you go through and check to see where your x value falls. Is your x value 0 greater than 2? No, so we're not using this one. Okay, is your x value 0 less than 0? No. Okay, so we're not going to use this one. But x equals 0, is that somewhere between 0 and 2 inclusive? Yes. So this is going to be the function that you use to evaluate 0. Okay, so we're using that middle one. So it's going to be 0 plus 1. 0 plus 1 is 1. Okay. All right, go ahead and try this one, letter C, and go ahead and evaluate f of 1. Try to determine which function you're going to use. So hit the pause button and come right back. Okay, so 1, our x value is 1. 1 is not less than 0. 1 is not greater than 2. 1 is between 0 and 2. So this is going to be the one that I use. So I'm going to plug 1 in to this middle one. And I get 2. Okay. Excellent. Go ahead and try this one. Go ahead and evaluate f of 2. Okay. So hit the pause button and come back. All right. So 2 falls over here. Okay. So I'm going to use this function, 2 plus 1, which is 3. Okay. Good. And try this one, f of 5. Hit the pause button and come back. So 5 falls over here. 5 is greater than 2, so I'm going to use this function. So 5 minus 2 squared. So that is going to be 3 squared, and that will give me 9. Okay, good. And try this last one. Go ahead and evaluate f of negative 2. Okay, hit the pause button and come right back. All right, negative 2, that falls over here. Number less than 0, so we're going to use 3x. So 3 times negative 2, and that gives me negative 6. Okay, good. All right, so that's how you work with a piecewise function. Okay, so let's take a look at evaluating without numbers. Okay, so evaluating without numbers. So instead of finding f of 3, we're going to be looking at maybe f of a, okay, or f of m. All right, evaluating without numbers. Okay, so let's suppose that we have this function, f of x equals 2x squared plus 3x minus 1, and we want to evaluate the following. Suppose that I want to evaluate f of a. Okay, so you still do exactly the same thing that we were doing up here, where you replace all of the x values with whatever you have here. Okay, it's just that in these, you were replacing the x values with a number and then doing the calculations. Okay, so here you will be replacing the x values with whatever you have here, but now instead of it being a number, it's going to be a letter. Okay, so, but nonetheless, you still have to replace all of the x's with a. So this is what we have, okay? And there really isn't anything you can do here with this, except for maybe remove the parentheses. So you just leave it. So these are actually supposed to be easier because you can't do the computations, okay, unless you know what A is, but we don't, okay? So that's how you would leave your answer, just like this. All right, let's take a look at this one. This is where it can get tricky when you have a negative letter. So just make sure you use parentheses. That way you don't leave your sign behind. Okay, so I'm going to replace all of the X's over here and here. Replace these X's with negative A and keep it in parentheses, okay? It will really help. 3 times negative A minus 1. And then when you work this out, you're actually going to be working out that negative. So here, negative A squared is negative A times negative A, which is positive A squared. And then here, 3 times negative becomes negative. So this would be your final answer. Okay, so this is about as tricky as these get when you have a negative. Just be careful with your signs. Okay. All right, so that's how you evaluate without numbers. Let's try a few. Let's try two more. Let's see if you can do this one. Okay, see if you can do this. Okay, and just kind of work that out. Okay, so you're going to replace all of the x's up here in this original function. Replace the x here and the x here. Replace them with a plus h. And then actually square this binomial right here and distribute that 3. And then combine your like terms and see what you get. Okay? So go ahead and see if you can do that one. Just, hit the pause button. And if you get stuck, then just come back here and see how this gets done. Okay. All right, so replacing the x values with a plus h. 3 times a plus h here. And then now I'm going to work out the binomial. So that's going to give me a squared plus 2ah plus h squared. And I'm going to do the distributive property with the 3 here. So I'm going to get 3a plus 3h. And then bring down that minus 1. And then here I'll distribute the 2. So 2a squared plus 4ah plus 2h squared. Okay, so I distributed the 2 there, and I'll bring down the 3a plus 3h minus 1. So let's bring that down. Okay, and do we have any like terms? Any like terms? I don't see any. All right, no like terms. Okay, so this is what you should have gotten. All right, so now this next one, I'm going to have you try. Don't freak out. It's a little more complex, but if you think you're really confident with this, see if you can try it on your own. Just hit the pause button. If not, then just watch. Okay, so I'm going to have you do f of a plus h, which you already found, but I'm also going to have you find f of a. Did we find f of a? Oh, it is up there. Okay, no cheating. Okay, so you're going to find f of a plus h. You're going to find f of a, and then you're going to subtract. And then we're going to have this h hanging out in the denominator. It's just going to hang out there for a bit until the very end. Okay, and just for technicality, h is not 0 because we don't want 0 in the denominator. Okay, so go ahead and see if you can do the subtraction up here. f of a plus h, which you already found, f of a, which we also found. But go ahead and do that, do the subtraction, and then see if you can combine like terms, see if you can cancel anything. All right. For those of you who are like, okay, I'm not even going to try that, that's fine. You can watch. So f of a plus h. So I'm just going to go ahead and start over. Okay, so that is 2. I'm plugging into here, a plus h. Okay, and I end up getting that, right? So we get 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Okay, so that is, let me just double check. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Okay, so this is what we get for f of a plus h. Okay, so that's the first part. And f of a is going to be, oops, where is my function? 2x squared plus 3x minus 1. So 2a squared plus 3a minus 1. Okay, so that's what we get when we plug in, when we do this part. F of a, we get this trinomial all over h. H is just hanging out. Okay, so let's go ahead and do the subtraction. 2a squared. I'm going to go ahead and remove the parentheses so that you can see that we have here. Okay, now right here, this subtraction gets distributed to everything in here. So this is going to be negative 2a squared minus 3a and plus 1. Okay, so negative 2a squared minus 3a plus 1. And h is just hanging out. Okay, let's see if we can cancel anything. 2a squared minus 2a squared. 3a minus 3a. Negative 1 plus 1. Okay, so a lot of things canceled out there. So what are we left with? 4ah plus 2h squared and plus 3h all over h. Okay, so we're not quite done here. Notice here that they all have what in common? All right, did you say h? Good. So they all have h in common. So I'm going to go ahead and factor out the h. And this is what we get. And now I can cancel the h's. So now that h I was hanging out thinking nothing was going to happen to it just got canceled. Okay, so 4a plus 2h plus 3 is the final answer. Okay. All right, so you just did a problem here that is called this here. Let's go all the way back up to the top. So this, let me use a different color. So this right here, what you just worked out, is a very big deal in calculus. I know we're not going to take calculus, but anyway, this is what we call the difference quotient. Okay, so you might see the directions say, oh, find the difference quotient between this. It means find that. Okay. Okay. Last part, net change. All right, so you're going to have some problems, some homework problems that say find the net change. So let's make sure you can do this one. This one's not so complicated. Okay, so the net change. So the net change of a function, whatever that function is, of f of x from a to b is f of b minus f of a. Because this is subtraction, the order does matter. Okay, so if they're asking you to find the net change of f of x from a to b, you need to make sure that you are finding f of b and then subtracting f of a. Okay. All right, so let's take a look at this example. Find the net change of f of x, which is x squared plus 1. So there's your function. From a to b. A is 1, b is 3. Okay? All right, so according to this formula, net change is f of b. So this is our a, this is our b. So it's f of 3 minus f of 1. Okay, make sure you go in the correct order. Okay, so f of 3 is going to be, I'll keep it in here. We'll do f of 3 in here minus, and then we'll do f of 1, the answer to f of 1 in here. Okay, so f of 3 is going to be 3 squared plus 1. F of 1 is going to be 1 squared plus 1. So that is going to be 9 plus 1. And this is going to be 1 plus 1. And so this will be 10 minus 2. And 10 minus 2 is 8. Okay, so that's how you find that change. Nothing too crazy, just probably some new vocabulary for you guys. All right, so that is it for 2.1. If you have any questions, make sure you message me through the Remind app, or you can email me. You get a quicker response from me if you send me a message through the Remind app. Okay, I will see you next time.